To think about what we are doing, especially me working close to this when I don't know the beam. I take off my watch because I don't want to have reflexes from anywhere, right? So I take off my watch and the light is going to come out divergent like this. And then I check here, is there anything that could reflect something? If there had been a cabinet standing here with the windows, you know, some of that light might have hit the window and come very nicely into here and eye over there. Just a little, sorry. So it looks like there is no shiny or no special things here. So what I will do, I will just capture the beam over here. It's half a watt. This is blue light, and you don't see very much. You see the bluish light. When I have the glasses on, I see reddish fluorescence. It induces fluorescence, you know. And of course, my eye is very good in the red region. So it's easier to see the faint fluorescence than the light itself at this value. Okay, so we'll do that, and you can all be some distance away, even you, Amal, you can go, yeah, because I will do it here. Okay. So okay, we'll.
Skulle du sänka ordinateur, sänka ardusen?
Okay, so you can see the blue light here coming out. It's quite divergent, as you can see. Quite divergent. And so the light, you see, it comes here. It's very divergent. And that light will now go into the eyepiece, right? So the eyepiece will then capture this divergent light through the lens, and the lens will focus it. It will go through a focus here. The beam will be expanding, coming out here, and this lens will make it parallel. And when we adjust this back and forth here, we will make it more or less parallel. So by turning this out and in later, we can make it to a very dense bright spot over there, which easily bounds anything. Or I can expand it out so it's 1 meter in diameter, right? So we have full possibilities to do that. You see, it's expanding very much. And that means an expanded beam is much less dangerous, because it's a question, how much of this light would pass through the pupil? And if it's a parallel beam, all of it will come to the pupil. But if it's 1 meter in diameter, it's a very small fraction. And that is what, of course, happens if you shine it in a very large distance and diverge it. Finally, it will be 10 meters in diameter. That is why it becomes eye safe. So eye safety has to do